Hello, ladies and gentlemen. We're going to continue our look at conformations of hydrocarbons. And that's a snipping tool. I don't want that. I got to go stop share. Sorry about this. Launch meeting. Snipping tool. Oh, yeah. We were on our previous example. That's why. So, chair is the conformation. It's how a cyclohexane looks. Chair. Conformation. Preferred, sorry. Conformation of cyclohexane. Now, please watch all the lecture videos on chairs. There are many. And it's got a step-by-step procedure on how to draw a chair. Please watch those before you review this. And the summary of why it's the most stable is when you go to a chair conformation, there's all the angles are 109.5, which is the perfect angle for an sp3 carbon, right? So there's no angle strain. You'll be watching and reading about that. And did we have a name for when there's a group in front of another group? We didn't. We had a name for when groups are evenly spaced. We called it staggered. But what happens when groups are on top of each other? It's like, think astronomy all day, please. This methyl is actually invisible because this group's in front of it, the red group, right? It's eclipsing it. So that is a form of steric hindrance. I'll call it steric hindrance number 1. Those groups are closer together. Well, why? Number 1. These groups are right on top of each other. That is not a good interaction. It's destabilizing. We're going to see a different form of steric hindrance with chairs. There will not be any eclipsing, but there's going to be a new thing called a 1,3 diaxial repulsion, which is totally foreign to you right now. So what was he just saying? I have no idea. But he did ask us to think about astronomy, and I think the word axial might refer to like the axis of the Earth. I'm not making that up. That's true. Okay. Okay. So cis 1-hexyl 2-isobutyl cyclohexane. You see that. More importantly, you see this question on the test. It's the one that says draw the 2 chairs. It's the only time you'll be asked to draw 2 chairs. Before you even finish reading, you're doing this. I haven't even finished reading part A yet. It's, oh, this is the 2-chair question. I'm going to do this no matter what. And everybody's going to do it the same way. Dr. Whitaker will tell you why. On a slight angle, draw 2 parallel lines that are the same length as each other. From the inside corner of each one of those, draw a long parallel line, but it's also on an angle, and draw it parallel to the one off the other inside carbon. You better be watching those videos because right now this is it's just zoning your brain. I don't know what's he doing. That is a chair. It doesn't look like a chair, but they called it one regardless. And I want everybody to have the same strategy drawing their first chair and their second chair. For one simple reason. You want a teacher to be in as calm and friendly a mindset as possible while grading your test, correct? This question can be made very difficult for my mind if everybody employs a different strategy to do it. Instead of taking 1 hour to grade, it'll take 2, and I'll be cranky. You don't want me cranky. I try not to be. I'll take breaks. If I get cranky, trust me, I do take breaks. It's for your defense as much as mine, okay? But if everybody does this strategy and says, okay, when I draw this one, I'm going to make Dr. Whitaker happy, make this 1 and this number 2. Okay? And then in the next chair, I'm doing something with my toys here that I should have done earlier, but I didn't. I just want you to see one thing in the little video. That's 7. It's my life. 7, 6. Okay. That's pretty much the carbons in a chair right there. Not the parallel lines properly. I'm trying. Bear with me. Almost had a visitor there. There we go. And I'll show you what I'm looking at. So there's one of our chairs. You see the parallel lines in the corners, up and down. This is pointing up. You can, yeah, there. And it's maybe better if I put some atoms on there. Just one atom on each one. Or this one. And another one. Okay, when we go from one chair to another, the sigma bonds rotate. And this purple is going to end up there. And this swings here. And we don't break any bonds. That was just me being a little too overzealous. Okay. The important thing is this angle now points down. And when you go to the other chair again, the same carbon angle points up. And that it's not being very clear with the video or there, but she's real close. My fingers are definitely not pointing down, they're pointing up, correct? And when I went to the other chair, now my fingers, they're pointing down. So please remember, when you do your 2 chairs, if this is carbon 1 pointing upwards, that angle toward that thing is definitely pointing in upwards, right? The other chair, which looks like the mirror image, but it's not, because you did sigma rotation, angled carbon, inside corner long, finish. Please do not call this carbon 1. That's pointing upwards the angle. When you do the sigma rotations on the chairs, all the carbons used to point up are going to point down. Here's the rotation. It's now down. And if everybody goes bottom right, Dr. Whitaker might be happy. Calm. Calm is the important thing. So you're going to do top right corner for carbon 1 in chair 1, bottom right carbon for carbon 1 in chair 2. Promise? And notice I only care about carbons 1 and 2 in this question. Why? Look at the question. There's only groups on 1 and 2. I need to see all the bonds on 1 and 2. There's 2 bonds missing on each carbon. Do you agree? Oh, you don't have the same handout? I gave the wrong handout.
Yeah, you got the wrong one.
Can you change yours to be this one just to save us time? The only change you need to make is cross out whatever words were on yours up to cyclohexane and fix it to be this. Because I think I gave another copy of the morning section by mistake. So thanks for pointing that out. Yeah, she's my editor-in-chief today. All right. So cis 1-hexyl 2-isobutyl. I only care about carbons 1 and 2 in this molecule. I need to see all the bonds off of those. And I'll tell you which bond I'm going to draw first. This bond on 1, this bond on 2, this bond on 1, this bond on 2, blue first equals axial. Like the axis of the Earth points straight up and down, correct? And it rotates around the axis? That's astronomy reference part 2. Okay? And why did I choose to draw those first? Because they're easy to predict which way they point. Which way is the carbon angle pointing? Which way is the carbon angle pointing? Up or down? Up. Which way is the axial bond pointing? Straight up. Which way is the carbon angle pointing for carbon 2? Down. How's the axial position? Straight down. Remember, whenever you say axial and you're asked to describe its direction, the first word out of your mouth is straight. Okay? Either straight up or straight down. Same for here, but our carbon angle is now down, isn't it? Axial straight down. Carbon angle is now up. Axial straight up. Equatorial's next. Hey, there's your other astronomy reference, right? What do you call that band around the middle of the Earth, the hot zone? The equator. The equator. And H's around the equator of the cyclohexane will be called equatorial. And they're easy to predict, but only after you've drawn the axial correctly. You want me to run through the only two scenarios? There's only two scenarios because every carbon needs to have an up group and a down group, period. If your axial was straight up, listen to how I describe your equatorial. Slightly down. Got it? Ready? Equatorial. Slightly down. And more importantly, I'm going to recolor this bond and this bond. Why do you think I found those to be special after I drew the equatorial? Parallel. The equatorial must be parallel to the adjacent carbon-carbon bond. What do I mean by that? Here's the adjacent carbon bond. It's not parallel, but the adjacent one to that is parallel to the equatorial you just drew. Same story for carbon 1 over here. Slightly up, parallel to this and this. Now talk to me about carbon 2. I'll switch to a baby blue for the equatorial and 2. Equatorial. Yeah, sorry, that's weird. Reds and blues, baby blues. Hey, if the axial is straight down, how do you think you're going to draw the equatorial? Don't say straight. Slightly is how I say on an angle. Yeah, slightly up or down. Up or down. You've already drawn it down. Yes. Parallel to not the red, but the baby blue and the baby blue. You like it? This one also slightly down, but don't do it this slightly down. That's not parallel to anything. Look, the one I just drew, terrible. Don't try it. You see it down there? It's awful. It had to go this way. How do I know? How did I know it had to go slightly down, but to the right? Parallel. Oh, that's awful. It doesn't even cover the other bond. Parallel. Parallel. Good. Yeah. Sorry? This one? What about it?
Yeah, for this one, we took the blue one, the short one.
Well, they're not short. I just drew them short. Same length? Because I'm not a good artist.
No, I don't mean the length. Like the color, you mean?
Oh, I just blew for color to be parallel with the blue, and these blues aren't parallel to anything. They're parallel to each other. I don't know the question. I'm sorry.
Can I show you?
Come on, yeah, sure. You might be on a video. Are you okay with that? Well, she's going to stay over there, so she doesn't have to be on the video.
This one was parallel to that.
Yeah.
Why isn't like the?
Don't forget, they're not the same bond anymore. I'm just doing equatorials in baby blue and red. They're not the same bond. You'll see when I finish this question. Because it's adjacent. Yeah, it's not parallel to the adjacent bond, but the next one. So blue is parallel, baby blue is parallel to not the adjacent, but the adjacent to the adjacent. Same here. Not the adjacent, but the adjacent. Or vice versa. And how do you decide where your groups go? Well, this is your executive decision time. Here is the hexagon version worth 0 points. Hexyl, top right, 1, 2, 3, 4, 5, 6. Going clockwise for isobutyl, 1, 2, 3 with a V. What does cis mean?
Same.
Same side, right? So you got to, for a drawing like this, you have to use wedges and dashes. And the best thing about chairs is there's no wedges and dashes anymore. You get rid of them. So do you want to go wedge, wedge? Or this morning we went wedge, wedge. We want to go dash, dash. Okay. Now, for the purposes of wedges and dashes in the future, you're going to have, this is the, for no better word, I call it the normal representation versus the chair. Normal, dashes become down in the chair, and wedges, not pictured here, become up in the chair. Okay? And I do want to remind you, you have an up bond and a down bond on each of your carbon 1s and 2s, right? Translate this. This is a down bond. Why? Because it's a dash. Which of these two is down on carbon 1? Please don't have a hard time with that. Which of these two is the one that's down? The red. That's got the hexyl group on it. 1, 2, 3, 4, 5, 6. Please don't leave the end of a stick in a molecule that doesn't have methyl in its name. Does it have methyl in its name? No. So what do you put on the end of the stick? You have to draw it. You can't always skip it. Not on this question. What is it? There's no group there. It's an H. You want to see the H? Watch. There it is. Has to be a wedge because you already used it that, right? Same story over here. That means the H is this bond, doesn't it? So convince yourself that saying wedge doesn't mean equatorial or axial, does it? Convince yourself.
Wait, what?
Wedge means up.
Okay.
Here, the up happens to be axial. Here, the up happens to be equatorial. There is no connection between the words axial, equatorial, and up or down. Okay, so don't try to think there is one. If the up was axial, the equatorial is slightly down. If the axial is down, straight down, then the equatorial is slightly up. That will never change. What's this group on carbon 2? Just a reminder, 1, 2, isobutyl. 1, 2, 3 with a V. Okay, now in the other chair, watch what's going on. Up and up stay the same. H was up in chair number 1. It better be up in chair number 2. Iso or hexyl was down in chair number 1. It better be down in chair number 2. 1, 2, 3, 4, 5, 6. H was up in chair number 1. It better be up in chair number 2. Isobutyl was down in chair number 1. It better be down in chair number 2. So you're going to be able to answer another question for me. What changes and what stays the same going from chair 1 to chair 2? You want to start with just using this H as an example. What stayed the same, H here versus H here?
No, H is on top.
The up, yeah. The up stayed up. That's all I want to hear. What changed though? H used to be on what kind of bond that was straight up? Axial. H is now on a bond that's only slightly up. Equatorial. Similarly for the groups, right? Is this axial or equatorial here? That's part of D, by the way. We have to label it. Equatorial. Now on the test, it says you can use the short form, EQ for that, and AX for this. So you told me it's EQ, right? Now what about the isobutyl group on the bottom? Right here. EQ or AX?
Yeah.
AX. Now, what about the hexyl group over here? AX or EQ?
Yeah.
So that's the thing that changes, right? And a group that used to be equatorial has to become axial, and a group that was axial has to become equatorial. But the group that used to be down is still down, and the other group happened to be down as well, and it's still down. Okay? Down stays down, up stays up, axial becomes equatorial, equatorial becomes axial. It kind of summarizes everything. Better save. And then we're gonna return to our discussion of bulky. If you had to, we do have a definition of bulky. Which one of these is branched closest to the cyclohexane? The isobutyl or the hexyl? Trick question. Hexyl doesn't have a branch at all. So, not really a trick question. I mean, come on, it's got a branch. Any branch on this is closer to the cyclohexane than the branch on this because there isn't one on this. That's why I'm going to go ahead and, well, you don't know why. I'm going to go ahead and circle this molecule for part C. And I'm going to do a little aside somewhere else that you don't need to have for your quiz or your test or this page. And I'm going to put it up top. And I'm going to, yeah, I know what I'm going to do. There's going to be, yeah, don't use orange enough in this class. So if you have a group here and anything over here, H or R can be anything. Let's put H there. I'll put another H here. There's a bad interaction here because they're close in space. Similarly, these are close in space. And believe it or not, the H's are close in space. And the orientation of the groups are on carbons 1 and 3 always. Look, if you call this 1, then it goes 1, 2, 3. That's a bad interaction. And it's called a 1,3 diaxial repulsion because they're close. Similarly, between the R and the H here, look, carbon 1, carbon 2, carbon 3. You're starting all over. Forget about what you called carbon 1 before. Carbon 1, carbon 2, carbon 3, 1,3 diaxial repulsion there. There's also a yellow interaction that's not so good. It's not as bad as the R with the H, though, because R is bigger, isn't it? R is a group, right? A carbon group, it's bigger. So it's going to be closer to the H's because the carbon's bigger. Yeah. But this is also a not so great interaction here. Even though they're tiny, they're still close, the H's. So it's also called a 1,3 diaxial repulsion. So I'm going to label that up there as a 1,3 diaxial repulsion in gray and yellow. 1,3 diaxial repulsion is steric hindrance number 2. What was steric hindrance number 1? It was when groups were on adjacent carbons and they were right behind each other and in front of each other. Call that eclipsed. The beautiful thing about chairs is there's no eclipsing at all on adjacent carbons. You're going to be looking at that in the video because it compares cyclohexane to cyclopentane to cyclobutane, and cyclohexane is the snizzle, as Snoop Dogg would say, because it doesn't have any eclipsing. Okay. And the reason I circled this is, read my words carefully. So C was the circle and D is the explanation. I need the bulkier word in here. The bulkier. Tell me which group's bulkier. Yeah, give me its name. I hear what you're saying. The one on 2 is what you're saying.
Yeah.
You're cool. The bulkier isobutyl avoids. Why does it avoid 1,3-dioxyl repulsion? Well, what kind of a bond is it on? It's labeled. It's not axial. What kind of a bond is the isobutyl on? Equatorial. Equatorial doesn't suffer from a 1,3-dioxyl repulsion. It's not axial. So if you're a group that's bulky, you prefer being equatorial. That's the main take-home message right there. And on the test, this is like a 6-point question, and the next version of this is an 8-point version of the question. So 14 total. And don't worry, we're going to do another practice one of this right now. Hopefully it matches what's on the screen. Okay. Okay. I'll leave that there for you. Let's maybe stop the video.